Hold on tight. We're blasting off into a historic moment where the impossible becomes possible. In the groundbreaking SpaceX Starship IFT-4 mission, both the colossal Starship and its super heavy booster nailed their first ever controlled splashdowns, rewriting the rules of space travel. Are you ready to rocket into a future where the stars are just a splash away? Join us on this epic journey right now. As we orbit around the success of today's mission, let's take a moment to marvel at the journey of SpaceX, a visionary company launched with a dream of making space travel accessible and sustainable. The Starship IFT-4 mission, a canvas painted against the vast, mysterious backdrop of the cosmos, represents a pivotal chapter in this ongoing saga of exploration and innovation. This mission is not just a technical achievement, it's a symphony of engineering and ambition, where every bolt, panel, and circuit tells a story of overcoming the odds. The Starship and its super heavy booster, designed for full reusability, mirror the relentless human spirit that looks to the stars and sees not just the unknown, but the familiar, the potential for future homes and adventures in distant worlds. With each test, each launch, SpaceX is stitching together the fabric of a future where the Earth and Mars are but stops on a much grander interstellar journey. The IFT-4 mission, with its controlled, graceful splashdowns in the embrace of Earth's oceans, stands as a testament to what humanity can achieve when we blend our dreams with determination. So, as we continue to watch SpaceX rewrite the history of tomorrow, remember that each rocket soaring through the sky is a beacon guiding us towards a more interconnected universe, full of beauty, mystery, and endless possibilities. In the historic SpaceX Starship Integrated Flight Test 4, IFT-4, both the Starship and its super heavy booster achieved controlled splashdowns for the first time, marking a significant milestone in the pursuit of fully reusable spacecraft. This achievement is crucial because it demonstrates a key capability for sustainable space travel, recovering and reusing the entire vehicle, not just parts of it. The success of these controlled splashdowns represents a leap forward in SpaceX's reusability ambitions. By managing to return both stages of the vehicle safely to Earth, SpaceX moves closer to its goal of making space travel more cost-effective and frequent, similar to air travel today. The splashdowns were carefully executed, with the super heavy booster touching down in the Gulf of Mexico and the Starship landing in the Indian Ocean. These events were part of a broader test flight aimed at refining the technologies and procedures that will enable routine, rapid reusability of space launch systems. This test was not just about demonstrating technical prowess, but also about ensuring that these massive structures could be safely brought back to Earth for refurbishment and reflight, which is essential for the next phase of space exploration. The ability to achieve controlled splashdowns reduces the risk and cost associated with space travel, making ambitious projects like Mars colonization more feasible. These developments are part of SpaceX's ongoing efforts to innovate and enhance the capabilities of its spacecraft systems, reinforcing its position at the forefront of the aerospace industry. The success of IFT-4 has paved the way for future tests and missions, which will continue to build on these initial achievements toward fully reusable spacecraft. Building on the remarkable achievement of controlled splashdowns, the focus of SpaceX's Starship IFT-4 was notably shifted from merely reaching orbit to demonstrating the advanced capability of returning and reusing both the Starship and its super heavy booster. This change in focus underscores a pivotal transition in space exploration strategies, prioritizing the sustainability of spacecraft to enable more frequent and cost-effective missions. The successful execution of this test involved complex maneuvers and technologies aimed at safely bringing back the spacecraft to Earth, a critical component of SpaceX's broader vision for space travel. By focusing on vehicle descent and recovery, SpaceX is working to perfect the procedures that allow for rapid turnaround and relaunch of their spacecraft. This includes not only the technical ability to land the spacecraft safely, but also ensuring that they can be refurbished and relaunched with minimal turnaround time. This shift is crucial because it represents a move from proving the technology's basic capabilities to fine-tuning systems for operational efficiency and reliability. Achieving and demonstrating this during IFT-4 was vital for validating the design and operational methodologies that will be essential for future long-duration and interplanetary missions. The emphasis on vehicle descent and recovery is a clear indication that SpaceX is preparing for the next phase of space exploration, where reusability is a key to expanding human presence beyond Earth. Such advancements are not just technical triumphs, but also strategic moves towards creating a sustainable model of space exploration that can support future missions to the Moon, Mars, and beyond. The ability to reuse spacecraft also aligns with broader environmental considerations, reducing waste and the need for new materials for each flight. Building on the impressive achievements of Starship IFT-4, substantial hardware and software improvements were crucial in enhancing the overall performance and reliability of the mission. These upgrades were integral to ensuring the spacecraft could not only achieve but also surpass the rigorous demands of controlled descent and reuse. Firstly, enhancements in the propellant filtration capabilities within the oxygen tanks were implemented. This development was essential to prevent issues such as filter blockage that had previously affected engine performance on earlier flights. By improving the filtration system, SpaceX aimed to ensure a smoother flow of oxygen to the engines, thereby reducing the risk of unexpected engine shutdowns during critical phases of the flight, such as landing. Space News. Additionally, The implementation of new hardware to increase the reliability of the Raptor engines in landing conditions was another significant step forward. The Raptor engines, known for their complexity and high performance, require precise control, especially during landing operations where stability and reliability are paramount. The new hardware introduced aimed to enhance these aspects, providing more robust engine performance under the varied and harsh conditions encountered during descent and landing. SpaceX. Moreover, the addition of roll control thrusters to improve attitude control redundancy was a critical update. Attitude control is crucial for maintaining the spacecraft's orientation and stability during re-entry and landing phases. Previously, issues with valve clogging had led to challenges in maintaining control over the vehicle's attitude. The added roll control thrusters provided a redundant capability, ensuring that even if one set of thrusters encountered issues, others could compensate, thus maintaining the necessary control and stability for a safe splashdown. Space News. These improvements not only represent technical enhancements but also reflect SpaceX's proactive approach to learning from past experiences and continuously refining their systems. Each of these advancements contributes to the broader goal of achieving rapid reusability in space travel, which is vital for the future of interplanetary exploration and the sustainability of such missions. Continuing with the focus on hardware and software improvements, the flight sequence and performance of Starship IFT-4 showcased some pivotal advancements that further underline the robustness and sophistication of SpaceX's approach. One of the standout features of this test flight was the successful execution of hot staging, a technique where certain engines remain ignited during the stage separation process. Specifically, only the three center Raptor engines stayed ignited, which allowed for a continuous thrust and smoother transition between the booster and the spacecraft stages. This method is crucial for maintaining the velocity and trajectory needed for the spacecraft to continue its mission post-separation. Hot staging is particularly challenging because it involves precise control and timing to ensure the safety and integrity of the vehicle during this critical phase. Additionally, there were significant adjustments to the fuel loading sequence. In previous flights, the standard procedure involved loading liquid oxygen before methane. However, for IFT-4, SpaceX optimized this process by starting with liquid methane before liquid oxygen. This change was aimed at improving the thermal and pressure conditions within the fuel tanks, thus enhancing the overall stability of the vehicle before liftoff. By adjusting the order of fuel loading, SpaceX was able to manage the temperatures more effectively, reducing the risk of ice formation and other issues related to propellant handling. These enhancements are not just incremental improvements, but are part of a broader strategy to optimize every aspect of the launch sequence. By continuously refining these processes, SpaceX enhances the efficiency and reliability of its launch operations, paving the way for more frequent and sustainable space missions. Each successful adjustment and innovation in the flight sequence and performance marks a step closer to achieving more ambitious goals in space exploration. The operational cadence improvements seen in SpaceX's Starship IFT-4 are indicative of the company's ability to rapidly evolve and refine its spaceflight operations. The reduced interval between flights, a notable decrease from previous tests, highlights SpaceX's growing efficiency and capability in managing complex space missions. For the Starship program, the time between successive flights has been steadily decreasing. For instance, the interval from IFT-1 to IFT-2 was 212 days, from IFT-2 to IFT-3 it was 117 days, and from IFT-3 to IFT-4 it was approximately 83 days. This reduction is significant because it reflects not only improvements in the physical construction and preparation of the spacecraft, but also enhancements in the logistical and support processes that underpin the entire operation. This quick iteration and improvement cycle is crucial for SpaceX's long-term goals, which include regular interplanetary travel and the establishment of a sustainable human presence on Mars. By streamlining and accelerating the preparation and recovery phases of the missions, SpaceX is working toward a future where spaceflights are as regular and reliable as commercial airline flights, thereby opening new frontiers in space exploration and utilization. These advancements in operational cadence are a testament to SpaceX's commitment to innovation and efficiency, setting new standards for what can be achieved in aerospace technology and exploration. Let's quickly recap the major points of today's incredible journey through the SpaceX Starship IFT-4 mission. Historic achievements. For the first time ever, both the Starship and its Super Heavy booster successfully achieved controlled splashdowns. Reusable spacecraft. This mission is a major milestone in the quest for fully reusable spacecraft, which is key to reducing costs and increasing the frequency of space missions. Successful splashdowns. The Super Heavy booster landed safely in the Gulf of Mexico, while the Starship touched down in the Indian Ocean, demonstrating controlled and safe recoveries. Sustainability in space travel. These advancements are crucial for sustainable space travel, focusing on recovering and reusing the entire vehicle, not just parts of it. Hardware and software enhancements. Significant improvements were made, including better propellant filtration, more reliable Raptor engines, and additional roll control thrusters. Operational efficiency. The mission highlighted SpaceX's growing efficiency, with reduced intervals between test flights, showcasing rapid advancements in spaceflight operations. Future goals. These achievements paved the way for more ambitious projects, including Mars colonization and regular interplanetary travel. With these groundbreaking developments, SpaceX is not just reaching for the stars but bringing them closer to us. Stay tuned for more updates on our journey to the cosmos. And that's how SpaceX's Starship IFT-4 mission is catapulting us into the future, transforming space travel into an adventure as routine as flying to another continent. If you were blown away by today's journey through cutting-edge aerospace achievements, smash that like button, and don't forget to subscribe for more stellar content. Join us as we continue to explore the cosmos and beyond. Until next time, keep looking up and dreaming big.